3.2b. We now know that if f double prime x equals 0, then we're going to have an inflection point. Okay, so we're going to start all over. We're going to make a problem. You've seen this particular problem before. And we're going to have an A, B, C, D, and E to do this problem, okay? So here's an f of x equals x cubed minus 3x plus 1. All right? Letter A, find the critical values. Find the critical values. We know critical values are when f prime of x equals 0. So the first thing we're going to do is solve for f prime of x. We're going to set that equal to 0. And we're going to factor out that 3. Okay, and we do this to find the critical values, in which in this case x equals -1 and x equals 1. All right, so there's our critical values. Letter B, find the critical points. Find the critical points. All right, to find the points, we're going to place our critical values into our original equation. And that equals 3. So one critical point is -1, 3. And we put the next critical value into our original equation. And that is -1. So these are our critical points. All right, I'm going to erase these so we have more room. Letter C. Find at which intervals f of x is increasing, decreasing. Okay, find at which intervals f of x is increasing, decreasing. Well, what we do is we list our critical values, -1 and 1. We look at our intervals. Here we have -1, -infinity, and our interval from -1 to 1. And then our interval here from 1 to infinity. And we test them. So last time we test 2, we said f prime of -2, because -2 is in here. It equaled 9, and 9 is greater than 0. So that was a positive. It was increasing. And then we tested 0 because 0 is there. So f prime of 0 equals -3. -3 is less than 0, so this becomes negative. And then we chose 2, and f prime of 2 equals 9, which is greater than 0. So we have increasing. So now we state where it's increasing and decreasing. So f is increasing on -1 to -infinity and 1 to infinity. So we have our pluses there for these intervals. And f is decreasing on -1 to 1. There's a minus sign there. Okay. We're going to keep going. Letter D. state the relative max and min. State the relative maximum and the relative minimum. Okay? The relative max is at point -1, 3, and the relative min is at point 1, -1. Letter E. Find at what intervals f of x is concaving up and concaving down. Oops, I forgot an N. Find at what intervals f of x is concaving up, concaving down. Okay, well, we know our first derivative we said was 3x squared minus 3. So our second derivative is going to be 6x. All right. So if we take the derivative, second derivative of -2, we get 6 times -2, which equals -12. Now, why did I choose -2? Because -2 was in that interval from -1 to -infinity. Okay, so I chose a -2, and when I put it in there, we get a -12. And -12 is less than 0, so we know it's going to concave down on the interval -1 to -infinity. So we do that with all of our intervals that we have. Okay. Actually, you may want to look at this way. We also have an inflection point. Okay, so we have -1 here, 1 here. Okay, and we said f double prime of -2 is less than 0. Therefore, it's concaving down from -1 to -infinity. Okay. Now, what's going on in here? Where's our inflection point? We know our inflection point is when f prime of x equals 0. When does that happen? Well, we know f double prime of x equals 6x. So if we put f double prime x equal to 0, divide by 6, x is 0. So right here at 0, we're going to have an inflection point. Inflection point. All right. So remember, it also inflects if we have concaving down and then concaving up. That's the inflection point. So most likely, since this is down, this must also be down, and then this is probably going to concave up and concave up. But we need to show that. Okay, so we're now going to look at an interval from 0 to -1. And here, let's test f double prime of -1/2, -0.5, -1/2. And that ends up to be 6 times -0.5, which equals -3. That's less than 0. So we know it concaves down between 0 and -1. Okay, let's try the other way now, from 0 to 1. We can test f double prime of 0.5. F double prime of 0.5 is 6 times 0.5, which is 3, which is greater than 0. and so therefore it's going to concave up. All right, our last point, we're looking at an interval from 1 to infinity. Let's pick 2 because 2 fits in there. F double prime 2 is 6 times 2, which equals 12, which is greater than 0, so we have concave up. So if we're now going to answer the question for concave down, we have an interval, this concaves down, so from 0 to negative infinity, F is concaving down. And now we're going to state where it concaves up. This is up and up, so from 0 to infinity, it concaves up. All right, one last part of the question I'm going to go on the next video.